So this question here, they said some grade 11 students were surveyed to determine the job sector in which they are most likely to seek employment after graduating. Their choices are represented on the pie chart shown below. So they give you a pie chart. Each one of these sectors, you could say, there is an allotted angle, right? So here we have 40.5, here we have 67.5, and the others are P's. This one here would be 90, okay? Government is 4P, 3P, 2P. I find this was one of the easiest question fives you could get. So, part one, they said to calculate the percentage of students who are likely to seek employment within the agriculture and the IT sectors, right? So let's look at agriculture. Are we seeing agriculture here? How much percent is agriculture? Well, not percent, how much degrees is agriculture? So 40.5 degrees represents agriculture, right? Then IT sectors, right? My IT sectors, well, the IT sector is represented by how much degrees here? Let me hear yours. 67.5 degrees. So, in order to find the percentage of the total pie chart, right? How much degrees is there in a circle? How much degrees is there? 360. So, watch me, we come in here, right? Part one. Okay? So 360, we want the percent, right? So it's a percent we're trying to find. So the percent will be equal to, is it correct to put 40.5 plus 67.5 all over 360? And it's a percent we're trying to find. So what do we multiply this by? Let me hear you. 100, proper. So how much percent we working with here? Okay? How much y'all got? 30, 30. Somebody had a secondness. Exactly 30. The next part of the question is asking us to find the value of P. Can I have your ideas on how we go about finding the value of P? Let me hear you. So y'all know I keep singing over and over that this changing the subject of our formula or making something the subject of our formula is the most important thing in mathematics. Being able to form equations and work back is very important, right? So we have all our sectors here, our sector angles. So let's write them out. And once I add all those sector angles, they would be equal to 360 degrees. So let's work, right? This is part two, right? So part two would be, we're going to start with 4P, right? I'll put all the P's together, right? So I have 4P plus 3P plus 2P, right? I put all the P's together. What else do I need to add here? Let me hear you all. 40.5, right? 67.5, proper, right?
Plus 90.
Plus 90. And all these things will be equal to what?
360.
360 degrees, right? This is a foundation equation that you have to solve here. So when we add all the p's together, how much p's would we get? Come on, y'all, speak up.
9.
9p, right? So 9p plus, when I add all my numbers on this side together, what would I get?
198.
198 flat.
Yeah.
And this is equal to 360. What do I do with the 198 when I carry it over here?
So you subtract it.
9p will be equal to 360, subtract 190. 9p will be equal to how much?
162.
162, proper thing. Then, in order to find p, what do I do with the 9?
Divided.
P is equal to 162 divided by 9. What is the value of P?
80.
880? 18. That's in 18. Say like I hear wrong, right? 18 and they just asked us to find the value of P. So the answer is 18. So we are on to June 2025, right? The paper that is I highlighted in the corner here is the one that we on, right? So you could just keep up to date with what you see in the corner here, right? So we have June 2025, number 5, right? Let's analyze this table. They said 30 students took a maths test. The marks they scored are shown in the table below, right? So those scoring 1, right? How many students scored 1? Let me see if you all know how to read this table. How many students scored 1?
3.
3. How many students scored 8? So make sure you know how to read your table, right? 6 students scored 8, right? Now, they gave you your frequency column. They gave you a tally. Now, your tally column basically is reflected by a frequency column, right? It's just the fancy tally strokes and that kind of thing, right? Now, cumulative frequency. Your cumulative frequency, you are adding coming down, right? So you're gonna have 3 plus 4 would give me 7. 7 plus 8 would give me what? So we would get 15 here. So that's one of the missing numbers. Then this one down here would be 19 plus 6 would give me how much?
25.
25, right? A whole mark just to do that, right? Now, I tell you, this January exam was extremely easy. And I believe that June coming real easy too, right? They said this was June 2025, right? So using the information in the table above, determine the range. Now, what you all need to know about range is the highest, highest
value take
Right.
away the lowest value.
Excellent, right? It's the highest or the greatest value minus the lowest value. So talk to me, what is the greatest value in my table above here? What it is? 10, right? And what is the lowest mark that someone could get here? 1. So this would be 10 minus 1. What would my range be? It would be 9. Talk done. So we go into the modal mark now. What does the word modal mean? Modal means most often, common. The one that is most common, right? So which one? Now they access the modal mark, meaning the mark that the most amount of students got. Which mark here represents the mark that the most amount of students got? 3. So your mode is 3, my children. It is not 8. If you put 8, you're going to lose your 1 mark, right? So your modal mark will simply be equal to 3. Right? Simple as that. Now, I told you all over and over, right? I just thought I made a blunder when I told Andrew, right? But for grouped data, it will be n, that's straight n, divided by 2 for your median. But for ungrouped data, in other words, data that does not have any class intervals. So you'll realize there are no class intervals here, right? For data that has no class intervals, it's simply going to be n plus 1 over 2, where n is the total number of students in this case, right? How many students do we have in all here, my children? Look, it's up here. 30 students, right? Now, the total amount of students will also be represented by your greatest cumulative frequency, right? The last cumulative frequency. So we go in. So this will be equal to 30 plus 1 divided by 2. Now, something we had to know about this. I put in this is equal to this. This is actually a median position, right? Your median position is going to be equal to 31 divided by 2 will be what? 15.5?
15.5.
So we're looking for the 15.5 student, right? Okay? So that now, when we find the mark that the 15.5 student got, this will be our median mark, right? Above there is my median position. What are we mapping out this? Here will be the first 3 students, right? Then 3 plus 4, first 7 students, right? So the first 3 students got 1, the next 4 students got 2, the next 8 students got 3s, right? So that means that the 15th student got 8 3. So what does that mean the 14th student got? The 14th student got what?
5.
5, which is the very next number, right? So your 15 student got a tree there. That will be the last student in this, well, getting a tree. So it's like you have 8 trees listed in a row, and then after that 15th number, which will represent the 15th student, your 16th student will be getting a 5. So how do we find the median mark? It will be the score of the 15th student plus the score of the 16th student. That will be where 15.5 would land, right? So 3 plus 5 divided by 2 will tell me that my median mark is what? What is my median mark here?
4.
4 marks. Food. So in order to find part 4, which is my mean mark would be equal to the summation of f multiplied by x divided by the summation of f, right? Now, what is f in this cumulative frequency table and what is x? X would be the marks. If it was grouped data, x would be the midpoint of each class interval. It is not group data, right? And your frequency, which is f, would be this column here. So proceed to find your summation of, well, you have to form a x multiplied by f column, right? That'll be the best move to make. Make an f multiplied by x column. Add up your f's. Well, you already know what your f's would be when you add it up. Divide them, find my mean. I'm giving you all 30 seconds. Let's first establish our f multiplied by x column, right? So the first one here, x would be 1, f would be 3. So give me the numbers coming on here. This will be 3. What the next one will be?
8.
8, right? Because it will be 2 multiplied by 4. Next we have
24.
next,
13.
next,
7.
next,
48.
next.
50.
Proper, right? So I need to find the summation of this column. This will be the summation of f multiplied by x. You're simply adding up everybody there. And you already know the summation of f is equal to 30, right? It will be all these added up here, which will be the students, the total amount of students in the class. So f multiplied by x would give me what? What did you all get? Come on, all of you. 255, bro?
155.
155, sorry. 155. Somebody had a second that to know.
Yes, sir.
155. So I'm coming back up here now, right? So my median mark would be equal to 155 divided by 30, which will give me what? What is my median mark?
5.17.
5.17, right? Proper thing. A bowling median is mean, eh? Mean. That's my mean mark, right? Right, so this is January 2025, number 5, right? The table below shows the marks out of 10, right? So all these are marks out of 10. You'll see how similar January 2025 and June 2025 are. I hope you all seen that, eh? So they said the table below shows marks out of 10 that 40 students in a class gain on an essay writing test, right? How many students got 8 out of 10? Let me make sure I look at the table. How many students got 8 out of 10? Come on.
7.
7 students. Excellent, right? So calculate the mean score on the test, right? So for those who don't know, your mean, is this grouped data or ungrouped data? What kind of data this is?
Ungrouped.
Ungrouped. There are no class intervals. I am sure there are students in this class hearing me thrown around that word class intervals. I don't even know what I'm talking about. For those who don't know, class intervals is like if you have like say 1 to 10 here, then you have 11 to 20, right? 21 to 30, etc. Once you don't have class intervals, right? You could use, when you're finding the median, you can use n over 2 once it's class intervals. If it's no class intervals, you would use n plus 1 divided by 2, right? But we find a mean here. So there we go. Mean will be equal to the summation of f multiplied by x divided by the summation of f, right? X is clearly marked here. F is clearly marked. So let's make an f multiply by X column. Hit me. Give me all the numbers coming on here.
4 by 3 is 12.
12.
6 by 9, 54.
How much? 64?
Yeah.
54. 54.
54. 55. Then 64. 54.
Yeah, 54 next.
7 by 8 is 60. 56. 56. Whatever. And another 56. 72 and 50. And you'll get 300.
Somebody second 300.
Yes,
Yeah,
sir.
sure.
Yes, sir.
Right? So when we add up these, we would get 300, right? So 300 would be the summation of F multiplied by X, right? So we're going to punch that in here. This will be equal to 300 divided by the summation of F would be how much? How much students in the class? 40. So summation of X was equal to 40. That'll be this column here. 40. So what will be my mean score? 7.5, right? So the modal mark would be the mark that occurred the most, the mark that the most amount of students got. 8. I don't even have to scroll up for that. That is 8, right? 8 students. How many students got 8? How many?
So the mark is actually 6 because
From what I remember, I know it wasn't 8, right? So the modal mark, I'm scrolling up, Hey, Ole, I just said it in the question before, and we came and did the same thing here. I'm saying it again. 9 students got 6. 9 is not the median mark. Not the median, sorry, the modal mark. 9 is not the modal mark, right? 6 is the modal mark because 9 students got 6. Okay? So I'm scrolling down here. 6 will be my answer. Now, median, I already spoke about median earlier, where I said once it is ungrouped data, you could use your median. So you have to find a median position first. This is median position would be equal to n plus 1 over 2. Now, if it was grouped data, aka data where we have class intervals, you could just use n over 1, right? N over 2, sorry. So what was the total amount of students there? Come on, you all hit me. So I want to scroll back up. 40 plus 1 all over 2. What would be my median position?
20.5.
So we're looking for the 20.5 students, right? So we're going up here. So this will be 3 plus 9 is how much? 3 plus 9 is?
12.
12. So this is 12. Then 12 plus 8.
20.
20. So up to the 20th student is here. Everybody agrees? So what mark did the 20th student get? Let me hear you.
7.
The 20th student got a 7. Now we're looking for 20.5. What did the 21st student get?
8.
8. Proper. Right? So in order to find my median, right, I'm going to do the same 7 plus 8. So therefore, your median mark would be equal to 7 plus 8 all over 2. My median mark would be 7.5. How it looking all? So they said, using the information in the table below, a pie chart is constructed to represent the marks gained, right? The student gained. So for 3, this is basically 3 less than or equal to x, which is less than or equal to 4. This simply means that we're talking about the numbers 3 and 4 here. How many students got 3 and 4? It was just 3 students, right? How many students got a 5 or a 6? 9 students. How many students got a 7 or an 8? 15 students. A 9 or a 10? 13 students. That's how you read this table. Calculate the angle for the sector representing the interval marks 5 less than or equal to x less than or equal to 6. Simply meaning that we're talking about the numbers 5 and 6 in the pie chart, right? How many students got 5 or 6? Let me hear you all.
9.
Excellent. So sector angle, let me hear all there. Sector angle will be 9 over what? 9 over what? Let me hear all you. Talk up.
Total numbers. Students.
Proper here, right? 9 over the total number of students because we're trying to find the fraction of an entire pie chart, which will be 360 degrees. That would represent 5 or 6. 5 less than or equal to x, less than or equal to 6. How many students we are in total here, my children? Talk to me. How much?
40.
40.
40.
Multiply by how much degrees in an entire circle?
360.
Boom. So what will be my sector angle representing 5 less than or equal to x less than or equal to 6? How much degrees? Lord Father.
So 72.
81.
I hear 81 and I hear 70. Give me Jeremiah. Right? So 9 over 40 multiplied by 360 would give us 81 degrees. Right? So, Mr. We on to A. Whenever all you're kind of unsure which year we doing, it will be highlighted in the left-hand corner here, right? If you're ever unsure which year we are on, right? So, we are on to June 2024, right? So, Mr. Morgan administered, somebody mic on, administered a spelling test to his class. The table below shows the number of words out of 10 that each student spelled correctly, right? So we have all our words here, and then we have our frequency. Just a little test to make sure that you know how to read this table. How many students got 9 out of 10? Anybody? 9 out of 10?
3, sir.
3 students. Proper. So, for the data set shown above, state the mode. What is the mode here? Which number of words did the most amount of students get correct? It will be 5, right? That is correct. 5 is the answer there. I need to go into no explanation there again, right? 8 students got 5. No other number of words did more students get correct, right? So we go in median. Is this group or ungrouped data? Talk to me. Ungrouped. So we're gonna find the median position first. The median position will be equal to n plus 1 over 2. Hitman. How many students in all?
23.
23. Are you sure?
Yes, it's 23.
Right. 23 plus 1 over 2 will give me what is my median position? 12. So we're looking for the 12th student. Hitman. How much did the 12th student get?
6.
Answer is 6.
6 words.
I ain't going into that no, right? Because watch, we are 8 students here. 8 plus 4 would be 12, right? 12 plus 2 would be 14. 14 plus 2 would be how much? 16. 16 plus 3. Wait, why going? Why going so far forward? Look at right here.
8 plus 4 is 12.
Yeah. That's how we calculate. Look at right here. The first 8 students got 5. The next 4 students got 6s. So we look at for the 12th student. That student got 6, right? I was just going on adding. Right? So let's work. So calculate the mean number of words spelled correctly, right? Mean number of words spelled correctly. So if we're looking for the mean number of words, right? Here's some things. This here would be my X, okay? My data would be my X. My frequency would be my F. So I need to form a F multiplied by X column. I'll put it on top here. F multiplied by X. Give me them. Hit me. 5 4s are, 5 by 8 is?
40.
Then?
24.
Then?
14.
Then?
16. 27.
Ooh, I put 18, yes? 27. 27, yeah. And what's the last one?
40.
And when we add up all these things here, what would be the summation of F multiplied by X?
161.
Somebody second now.
Yes, sir. Okay.
Right. 161, right? So my mean, and what was the total frequency? 23, right? 23. 23 was the total amount of students. We already worked out that, right? So my mean would be equal to this symbol means summation of F multiplied by X divided by the summation of F. That will be 161 divided by 23. What is my mean here, my children?
7.
70 who?
7.
7.
7 flat.
Yes, sir.
So we on to part B. They said the attendance officer at a particular school recorded the time T in minutes taken by each student in a group to travel to travel to school, right? Look at our white one earlier. Put on the white one right there, the white one. So the data collected is shown on the cumulative frequency curve below, right? So how this data works, underneath here will be the time in minutes. Your cumulative frequency is on this column, right? So they wanted us, they said, using the cumulative frequency curve, find an estimate of the number of students who took at most 32 minutes to travel to school, right? So what we counting here? We counting in twos. Everybody agrees? We counting in twos. So this will be 32, 34, 36, 38, then 40, right? So 32 will be this bad boy here. So we're going up. Bang, 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 bang. So we here, and then we're going across here. Bang, 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 bang. Now what you catch here? What you catch here? We have 40 here and we have 60 here. So we counting in fours here. This will be 44, 48. This will be 52, right? Then this will be 56, and then you have 60. So the number of students who took at most 32 minutes to travel to school would be equal to 52 students. Everybody good here? There we go. So the next part is they want us to find the interquartile range. For those who don't know what the interquartile range is, this will be equal to Q3 minus Q1, right? Q3 being between the median and the greatest amount of data, and then Q1 will be between 0 and a median, right? So in order to find Q3, or Q3 occurs at one quarter will be Q1. 3/4, right? 3/4 of your total data, which is N, right? So what is N here? The total amount of data in this question will be the greatest cumulative frequency up here, which is 220, right? So 3/4 of N would give me Q3, and then Q1 occurs at 1/4 of the total amount. Is it students? Yeah, students, right? Right. 1/3 of the 1/4 of the total amount of data, right? Or students. Now I want you to find Q1, find Q3, minus it for me. So this will be N is equal to 220. Let me do it one time now. 3/4 multiplied by 220. Tell me what you're getting there.
165.
165, all right. So this will be 165. And what down here will be?
55.
55?
Yeah.
Right. So we go into our graph now. So you know what 55 first. So where would 55 be by? 55 students, eh? So we're going on our cumulative frequency curve. This is 52. This is 56. So 55 should be right under 56 here. So we come in here. So bang. All right. So we're going with 33 for when it's 55 students. So this will actually be a Q. This is your Q1 here. Q1 is equal to 33. Then Q3 occurs when, occurs at 165, right? That is when Q3 occurs. 165, right? So let me see what's going on here. This will be 162, 166, right? So we coming right on that 166. We're going across here. Boom. This one looking like it's dropping exactly on this line here. So we coming down here.
So I think it might be 54.
Yeah, that one again exactly 54 proper. I can get the autocorrect there, boy. Hold on, huh? Right, exactly 54, right? So 54, this is Q3. Q3 is equal to 54, right? So therefore, our interquartile range now, somebody trying to... So once you have Q1, once you have Q3, you can proceed to find your interquartile range now, right? So this will simply be equal to here. It was 54 minus 33. 54.
You get 21.
Where again?
21.
21, right? That will be my interquartile range. If they ever ask you for semi-interquartile range, right? That will be Q3 minus Q1 all over 2. If they ever ask you to find that, right? Everybody got the mass M, by the way, this is January 2024, right? The mass M in kilometers of 120 newborns at a hospital is recorded on the table below. So you have from 2.6 going straight up to 3.5. 7 babies had masses in between those numbers, right? Including 3.5. Now, this question here has class intervals, right? All of these are class intervals, right? You have 3.5 to 4.5, 18 babies, etc. Which class represents the modal class of masses here? Let me hear you all. Which class had the most babies? Go ahead.
Less than. It's less than or equal to 5.5.
5.5?
5.3.
Right. So 4.4 less than, no, it's less than M. Right? Less than M. Less than or equal to 5.3 because we had 30 babies with masses in this class interval, right? So we're going now. Complete the table below and calculate an estimate of the mean mass of the 120 newborn babies. Now, you all realize they calculated the median, well, the midpoint, sorry, by adding these two numbers and divided by 2. So what you all got for here? What is missing here? Let me hear you all. Hello.
5.75.
5.75. Somebody second that.
Correct.
Next one down here.
7.55.
7.55, right? Now, to find my frequency multiplied by midpoint column, which is F multiplied by X, you are multiplying the midpoint by the frequency to get what here?
166.75.
Somebody second that.
Yeah.
Yes, sir.
Last column.
60.4.
60.
Yes, sir.
60.4.
Right. So, in order to find my mean, because they ask you for an estimate for the mean, right? My mean would be equal to the summation of F multiplied by X divided by the summation of F. Help me out here. What we got for the summation of F multiplied by X? And, well, we know the summation of F. The summation of F is already above here. Is 120 newborns, right? So give me the answer here. What you get when you add up all these bad boys?
651.3.
So 651.3 divided by
120, and you'll get 5.42.
5.4 who?
5.43.
Oh, my bad. I didn't.
I have 4.3 and I have 4.2.
5.43.
3, right? That will be my mean mass, right? See, my favorite thing in the world is probability. So the newborn, well, one newborn, sorry, is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms, right? Let's see if we can figure out how many newborns have masses greater than 5.3. Who we talking about? Let me hear you all. Which babies we talking about? Come on. Which babies here have a mass of 5.3 or greater? We are talking about the baby, well, these 29 babies with weights in between 5.3 and 6.2, 6.2 to 7.1, 7.1 to 80, right? So when I add up 29, 28, and 8, how much would I get?
65.
65.
So the probability, or we could just put P, probability of greater than 5.3 kilograms would be equal to what you got again? A, I put in 29 plus 28 plus 8 all over. How much babies we had in total?
120.
120.
Right, so give me it as a fraction. What would be? 65 over.
55 over 120.
And when we break this down, what it can be broken down to be as a fraction. Leave it as a fraction.
13 over 24.
1 mark in the bag, right? Complete the cumulative frequency table shown below, right? So the first one would have been 7 plus what? 7 plus 18 would give me 25. 25 plus 30 would give me 55. Then we'll have 55 plus 29. What are you getting there? So it'll be 55 plus 29 will give me what?
84.
So to get this one is 55 plus 29, which will be 80, 81, you all said?
84.
84. 84. And then here will be 84. I believe the next one was 28. Where again there?
112.
And then 112 plus 8 supposed to give you the 120 because it's 120 is the total amount of babies, right? Our next mark in the bag, right? Ooh, we have a nice scheme. Hey, while I'm drawing this, I might get time to do my thing, you know. What they asked you to do? Oh no, they just asked you to on the grid draw the cumulative frequency. Come on, do this. Do this now. Let me see if I can go and get my thing done quick. It's something that break inside there and I had to fix it, boy. Right? Give me a minute. I'll come back. Draw this line meanwhile. This might take only a little 3 minutes. I really don't want to end class now. I want to pump all you. So let's work with me now. Work with me. Camera on, boy, Abby. I don't know if I go pick you up, boy. Take all them cameras, yes? Hey, I'm just gonna hold you, boy.
I could try. You sure? I drilled a lot of drill meals. That's why I drilled a lot of meals. You showed me how to drill a nail. May I please drill? Please. Please. Oh. Olha, full TV. Olha, OLED TV. And we just have a normal cable. You know how hard it is to watch stuff on ours? You can see mother connecting it. You know what's the saying? Before he died, there's no chocolate. Yeah, no, this is a lot of business. While he had contact with this is what are you doing? What's the problem? 57, 56. I believe 56, 50, right? $59 included all of you.
Ni man gärna kan få det ihop. Oh, like can I even see? Let's see the meatballs inside of these. Yes. Huh?
If you like, if you're gentle, if you're. Yes, Dad.
Kiana, you can follow food. Okay, Kiana, come for food.
Yeah, go play food. I don't want to go boom, boom, boom.
Right, this is yours. Yes, what's on it?
Yes, yours. Oh, I know. Just make it fun. What is that?
It's for passion. Just for fun, sweetness. I'll give you a fork right now.
But it doesn't taste like anything, so like, is that?
No. Wait, you get my film.
Yeah,
No, actually,
I don't jalapeno.
Actually,
I don't chill.
not eating this.
Make up with mine, I'll let them check. Take this.
I can get more after, right?
I feel Xenon's calling me. Hey, boy. Full of sweat, yes.
Until then,
Full of sweat.
So you gotta get the tables here.
The tape, oh good. All I got the table there.
Yeah, to get the values. The chart.
Good. All we go really had to do this one and then call it a night, yes. Sorry about that, boy. I had a little situation on me. Let me do it out now. Let me still do out this one. We do now this one, right? What we had to draw here? Remember, it's the upper class boundary using, right? The upper class, well, they're using 2.5, 3.5, 4.4. This will be 4.4, and then what? They're using these 3.5, 4.4, 5.3, 5.3 for the next one. So let me do it. 5.3, which will be like here, 5.3, comma, 5.3, comma, 55, right? 50, let me go. 50 is here, 50, oh, they counted in twos. 54, 55 will be in between here. Boom. Right? Then the next one will be 6.2. 6.2 is 6.2 is here, right?
84.
Right. 84. So we're going up, and up. 84 would be right here. Boom. Right. Then the next one would be 7.1, 112, right? 7.1 will be here because here is 7.0 earlier. 7.1 is here. 1112 will be 1112 is up here. Yeah, up here. Right here. Boom. And then the last one is what? 8.0 and 120. So 8.0 would be in the middle here. And 120 would be here. So let me draw that now, right? Insert. I wonder if I could right, so this here would be my cumulative frequency curve. Then they proceeded to say use your diagram to find an estimate for the median mass of the newborns, right? So the median mass of the newborns, if I want to find the median amount of newborns, I could just do n, right? So your median position would be equal to just n divided by 2. I believe it was 120 babies divided by 2. So we're looking for the 60th baby. Cool? So we go in here now. Boom. We're coming across. Let me do it in a different color. 60. What 60 line up with here, boy? What you all getting on your end? It looking like in between here, boy. 5 point. So this will be 5.4 for me. 5 point. So this will be 5.45 for me. I'm getting 5.45 from my cumulative frequency curve, right? So my median mass from my own, what you get here, Andrew?
My one come now on the time and get 5.
5.4. All right. Anybody else get 5.4?
Yes, sir. 5.4.
Right. So I get 5.45 kilograms as my median mass, right? So the cumulative frequency curve below shows information about the times taken by 20 students to solve a mathematics Olympiad problem, right? So if you look at your x-axis, you would see we have our time in minutes, right? All down here, the x-axis represents our time, right? This is my x-axis. Then our cumulative frequency axis, which is my y-axis, would represent the amount of students, right? Reaching as high as 200 students, which is the total amount of students here. So let's see what the question is asking. They said using the cumulative frequency curve shown above, find an estimate for the number of students who took more than 50 minutes, right? Than 150 minutes, right? More than, right? Now, if we want to find more than 50 minutes, did I say 150? I think I did. More than 50 minutes, right? So we go to the x-axis, which represents our time. We're going to draw a line from 50 going straight up here, right? To meet our cumulative frequency curve. It meets it right there. And then we're going to go across
So I reckon like 196.
proper thing, Andrew.
So I get like 195 somebody.
You draw it? Or you're just watching it here?
So and each small block could be 4.
Yep. Right? So I want to show you all that, right? So let me go across. Yeah. Boom. Want to get the autocorrect right. Proper. Boom. Right? Now look at something here. If here is 180 and here is 200, that means between here we have 20. You can say 20 students, right? Or 20 units. Now, in between, we have 5 spaces. So to find out how much one small box represents, I will do 5 into 20, which will give me 4. So each small box here represents 4. So this will be 184, 188, 192, and here will be 196, right? 196 would be the amount of students who got 50 or less. But if the question asks us for how many students took 50 or less minutes, I want to hear you all. Did the question say 50 or less minutes?
No.
No, 50 or more. So who are the children we talking about, Dred? Who are the children we are speaking about?
Take away 196.
Proper. So number of students would be equal to 200, which is the total amount of students minus the 196 who took 50 minutes or less, and we're talking about 4 students. Proper thing. So once again, 196 would be the students who got 50 or less, right? If I want more than 50, it would be 200, which represents the total amount of students minus the 196. So, part 2, the median time taken to solve the problem. So I want the median time taken, right? So in order to find the median time, I need to find the median position or the median number of students, right? So your median position, because this is a cumulative frequency curve, we're going to just use n divided by 2, right? N representing the total number of students. What was the total amount of students? How much students? Come on, guys. I don't know that. All paying attention. 200 divided by 2, which is equal to the 100 student we are looking for, right? So we're looking for the 100th person or the 100th student, right? So let's draw a line from the 100th student up here, right? So there we go. We coming from 100 across the cumulative frequency curve. Look in there, Andrew. Preston. I find looking in between here.
33.5.
33, yes, 33. Watch, that'll be 33, because here will be 33, right? And here will be 34. So we're going with 33.5, right? 33.5 minutes would represent my median time. So I'll come here and just put therefore, right? So therefore, median time would be equal to 33.5 minutes. Are we looking there?
So if you put 30,
So the next they want us to calculate the probability that a student chosen at random took at most 28 minutes. So if it's at most 28 minutes, am I talking about 28 minutes or less? Or 28 minutes or more?
28 or less.
Right. So we're talking about less than or equal to 28, right? That is the probability that we are looking for. So brothers and sisters, you know what we're going to do here? We're going to locate the amount of students who took 28 minutes or less, right? That would be, we go into the minutes column, right? So let me do it in red, right? I'll put this one a little thicker too, right? 28 will be whereby 28 will be here, Thomas. Coming up, boom. Oh, good, this one exact.
64.
This one exact. I'm sure this one exact. Right, this one is exactly 64.
64.
Yeah. Right? Well, I ain't get you to correct, but I run it. 64, right? So this one would be exactly 64. But my children, this is a probability. So it'll be 64 out of how many students do we have in all? Come on, man. We cooking. So break this down for me. Quickly. Come on, we ain't coming to stick today, you know. Break this down for me.
8 over 25.
8 over 25, proper. That's the probability of choosing a student that took 28 minutes or less, right? So, using the cumulative frequency curve above, complete the table below, right? So, we have our frequencies here. Now, what we'll be able to figure out here from the cumulative frequency above will be the cumulative frequency column, right? So let me see what's going on for here. So here we're looking at 20, which is the upper class limit. And we check. Let's see what it lines up with. Because the first one will be 12. If I put a cumulative frequency column, right? There is no cumulative frequency column. The first number would be 12. Let's see what the second number would be. Right? So 12 is the first. So 12. Right? Hold on. So they want us to complete this frequency curve. It's not even a cumulative frequency curve. Table. It's a frequency table, right? So you have your midpoint, which will be the number in between these two upper class limit and lower class limit, right? That's the midpoint. Then you have your frequency. Your first frequency was 12, which means your first cumulative frequency would be 12. Then 12 plus some number would give you 34. Now 20 and whatever number 20 lines up with on the cumulative frequency curve are going to scroll up. 20 lined up with 34. It's in between 32 and 36. In between 32 and 36 would be 34. I took that 34, I just wrote it on the side here. Because if you were to calculate your cumulative frequency column, it would be your cumulative frequency plus your next frequency would give me 34. So 12 plus some number would give me 34. That number would be 22. All right. Now, the last missing digit there would be very easy to find, right? I could just add up all and minus it from 120. Can somebody do that, please?
Yeah, I get 36.
36. Let me make it happen. 36. Tell her I love these all. Right. So down here, where get Andrew?
36.
Right? 36, right? How did Andrew get that? We did 200, which is the total amount of students, minus all the other frequencies. Right? 42 plus 84 plus 4. And when you work out that, you would get 36, right? Somebody second that. So let me go. We need to complete our frequency multiplied by midpoint column. Come on. You all work with me now. Point a note. It's not going to be the midpoint multiplied by the cumulative frequency. Well, the 34 I put here. It's going to be the midpoint multiplied by 22. What will we get here? Come on. 300 and how much?
41.
And down here, 45.5 multiplied by 36 will give me
1628.
1628. Everybody good here?
No, 1638.
38. Sorry about that. 38. Everybody good here, right? I tell you, like, get involved, right? Using the information in the completed table above, calculate an estimate for the average time taken by the students to solve the problem. Average. What is average? Average is mean. Come on. Come on, all here. Mean is equal to the summation of f multiplied by x divided by the summation of
F.
proper. So we already know the summation of f, which is this column, would be 200, right? But what is the summation of f multiplied by x, which is this column here? Did anybody calculate it?
Yeah, I get 6,320.
6,420. We need somebody to second 320. Can someone else second this, please? Or it's supposed to be going lightning speed on that calculator.
Yes, sir.
Proper. 320, right? So let you go. This will be equal to 6320 divided by 200. What is my mean?
31.
My mean mass.
31.6
Well, meantime, this is what? 31 point?
minutes.
Minutes. Proper thing. All of you. Right. So we on to June 2022, number 5. So a school nurse records the height H. So let me, we're gonna try to understand what's going on with this first part, right? So she records the height H of each of the 150 students in class A who was vaccinated, right? The table below shows the information. So, Lockheed, how much students it have in the class? That's the first question asking. How many students it has in the class?
150.
150. Everybody able to articulate that, right? Let me ask our next question. How many students have a height between 140 to 160? How many students?
20.
20. Who is not able to see that? Raise your hand if you are not able to see that. So we know how to read our table. Let's proceed to see what the question is asking. Complete the table below and use the information to calculate an estimate of the mean height of the students. Give your answer correct to one decimal, please. So it's not supposed to be triggering that mean formula in all your head. All you're supposed to then be seeing summation of f multiplied by x divided by summation of f, right? CXC laid out on a platter here for you. They have the column that is representing f. Look at here, big and bad, right? This is your f column here, boom, right? You have your x column here, boom. You have your f multiplied by x column, right? So you should have already mapped that out in your brain. Now, the midpoint, if you calculate, your midpoint would actually be like the first number plus the second number divided by 2. So can someone tell me what the midpoint that is missing here would be?
130.
130, right? So another thing here, there's a trend. So it's going up by 20. You all realize that? All that you could have watched, right? Then we need f multiplied by x. Can someone tell me what f multiplied by x?
8,710.
Proper, right? So all you should have already done, initiate that mean formula and all your big head already. That mean formula should not be clocking in all your head already, right? So mean would be equal to the summation of f multiplied by x divided by the summation of f, right? What is the summation of f multiplied by x? Did anybody work it out?
18,320.
Proper boy, daddy kind of efficiency we looking for. 18,320, right? Look at right on the side there. That is this A. I sure plenty people here not understanding what I mean when I say summation. Could somebody ask, Jovel, what I mean when I say summation, Jovel? So 18,320 divided by 150, which is the summation of f, would be equal to,
122.13.
and this would be this is what, height, centimeters.
Yeah.
So, let me
This-
say like,
Uh-huh.
the 130 measurement, right? And upper units. I could still get like
Yeah, put the centimeters. I'm not sure. So a small standard deviation. Well, wait. Let me show you all the question we're gonna do, right? In class B, the mean height of the students is 123.5 centimeters, and the standard deviation is 29.87. For class A, the standard deviation is 21.38. Using the information provided and your response in A, comment on the distribution of the heights of the students in both class A and B. So I went on to say that a small standard deviation means the values are close to the mean. A larger standard deviation means that the values are more spread out. So we're dealing with class A and we're dealing with class B, right? Now, class A has the smaller. Class A has the smaller standard deviation. Class B has a larger standard deviation. So you know what that means? For class A, what was the mean of class A? The mean of class A was what we calculated above here. 121.
122.1.
Right, so I'll put my mean here, 122.1, right? And then for class B, I would put my mean, what did I say? They just give us it there,
123.5.
1.5, right? So because the standard deviation of class A is lesser, it means that all the other values of the, what we dealing with? Students, right? All the other values of the heights of the students are close to this mean, right? So you have like all the other values like close around here, right? Boom. All of them jumble up here, and you probably have a 1 or 2 out here, right? Whereas for class B, it would be the more out here, right? The more out here, the more far apart, right? Okay? And you probably have 1 or 2 here, they basically further apart from the mean, right? So this standard deviation here was 21.38, right? 21.38. And the other one was 29.87, right? So we're going to write something to that effect. Okay? It's just a little statement. So I can say the data in class A are closer to the mean of 122.1 centimeters because, and I'm going to put down the data in class A are closer to the mean of 122 centimeters than class B because, well, class B with a mean, all right, that's I'm going to put the mean here with a mean of 123.5 centimeters because the standard deviation of class A is less than the standard deviation of class B. Boom. So class A, right? Class A. Let me make this a little smaller. You can zoom in on the out on your end there and make sure you have everything here. This is very important. Again, a little tingle telling me that, a small question. It's possible that it could come. So we on to part C. They said complete the cumulative frequency table below and use the information to construct your cumulative frequency curve on the grid on page 19. This is the grid they are speaking about, right? So let's first complete this cumulative frequency table. So for those who have no idea what is going on here, you're adding 24 to 35, which is the cumulative frequency from the class interval before to the current frequency here in this class interval to get my next cumulative frequency. What would it be?
59.
59.
126 plus
146. 146.
A. All I don't know how hearing so much people answer is music to my ears. No, all I continue to answer, right? I love that, right? Make noise in my head. Let me go. So we have to complete the graph, right? So 120 comma what by 120 comma 59. Cool? So let's go. 120 comma 59. What we counting in? We counting in twos?
Twos.
52, 54, 56, 58, 59 will be in between 58 and 60. So we're looking at here, boom. Proper. 140 is there, 160 is missing, yeah, 160 comma what? So you look at the upper class limit here, right? And you look at the cumulative frequency. So it's 160 comma 146. So 146 will be right here. This will be 142, 144, 146. Boom. Right? So let's draw our cumulative frequency curve. We come in, boom. Right? I just do two at a time, right? Bang. Right? Sometimes it does, this is like a real-time exercise here. Sometimes it does mess up piece. You're going here now. Bang. Then we coming up. Bang. Then we go in here now. Right, then you come in here. Bang. Then you come in here. Boom. Right, so I messed up that last part there. Somebody mic on. Observe what I did. Tunisia, you get this? Tunisia, you get this?
Yes, sir.
Proper. Right. Just making sure you all have that scrolling down. Good. Right. So we finished our cumulative frequency curve. We are going to do part 2A here. an estimate of the median height of the group of students, right? The median height of the group of students would be, now because this is a cumulative frequency curve, your median position would be equal to n divided by 2. That would be, n is how much? How much students we had in all?
150.
150?
Yeah.
So we're looking for the 75th. We're looking for the height of the 75th student, right? Okay, so the height of the 75th student. So let me get it right now.
So on my graph, I get 126.
All right, let me see what I get in here. Hold on, boom. Good, I get something exact, boy. Exactly on our line here, boy. I get 124, bro. I get 124 because we counted in twos. Big brother, I get 124 exact. Because here's 130.
Yes, I get that too.
Right, I get 124 exact. 124. Right? So that means my median height are going up, right? So therefore, median height. What you getting on yours? Gibral, what you get? The probability that a student chosen at random would be taller than 130 centimeters. So looking for the probability of greater than 130 centimeters. Greater than 130. So let's see how many students are greater than 130 centimeters. Then we could proceed to find the probability. Look, I so graciously had the 130 already marked out here, right? 130 centimeters. So coming up here, should I go in a different color? Yes, I should. Let me roll in green. All right. So we going boom, bang. We going up here. What again on all your own? So I think mine need to be around that. 98. I get 94.
93.
Right. I get 94.
So I get 94.
Right. I work with my 94. I get 94. Right. So this will be 94 students get 130 or lesser. 130 from 0 to 130 would be 94 students. But what did the question ask? They wanted great. Where I going, by? I had to go up. They wanted greater than 130. So if I want greater than 130, it would be 150 minus the 94 all over 150. And what this would be?
Yeah, I get 6 over 150.
56 over 150, which could be broken down to be
28 over 75.
no, 28 over 75 is my answer for my graph. All right. Some of you all have a little variation in your answer. 28 over what? 75.
75.
Right. That is my. So we are on to January 2022. They said the cumulative frequency diagram below shows information about the distance, d kilometers, that each of 120 students walks to school on a particular day. So we have the distance underneath here, cumulative frequency, that will be a students over here. How many students walked at most 1 kilometers? If I say at most 1 kilometers, what am I talking about? 1 kilometer? 1 kilometer more or 1 kilometer and less? Less.
1 kilometer and less.
Right. So I have number of students would be equal to, we have to go to our cumulative frequency curve. Right. So I would go on one. This is 1 kilometer here. I would proceed to draw a line straight up to my curve and I'm going across. How much is looking like there earlier?
46.
46? Nah.
What's it? Oh, 38.
36. This is 30. 32, 34, 36. Nah, that's 36, bro. 32, 32, 34. Watch it. 32 is here. 34, 36, and 38 there. Yeah. Right? So number of students. Oh, so that your eyes.
Well, it's real small, sir.
It does, it does. So number of students would be 30. Wait, at most would be 1 kilometer or less, right? So it's like less than or equal to 1 kilometer. That would be the 38 students, right? If I said more than 1 kilometer, I would have had to do the total amount of students minus 38, but it's less than or equal to 1 kilometer. So let's work.
So it's 36.
So it's not 36.
Well, you see, all let's say in 38, or make me put 38. You see what I'm talking about? 36. Hey, I don't know how much I just enjoy to teach, but I just wish all I could just enjoy to listen. Let go. Median. Using a frequency diagram, determine the estimate for the median, right? So your median, because it's a cumulative frequency curve, it will be n divided by 2. And what is the total amount of students? Did they say?
120.
120. Big up yourself. So let go. 120 divided by 2. We're looking for the what student? The 60 odd student, right?
60.
So let's look. Let me go to a different color. We're going in green. 60. Let me see how much kilometers Big Man was hitting.
So I get 1.3.
I don't know how much we counting in here. That's Let me see. We coming on this one here. Even though I'll shift a little bit. Hold on. Let me get our back straight. I don't know why it does do that. And I'm going right down to Chinatown. Right. All you know what I mean here. Right. So here is 0.1. Here is 1.5. So we're basically looking for every 2 is 1. So this will be 1.1, 1.2, 1.3, 1.4, and then 1.5. Somebody mic on. Right? So this will be 1.3. Okay? 1.3 kilometers will be my median. So write that in, please, guys. So therefore, your median distance would be equal to 1.3 kilometers, right? Lower quartile. So something you have to understand about lower quartile. Somebody might only comment on my lower quartile occurs at 1/4 of n, right? We call this Q1, right? So we're trying to locate where our lower quartile, well, this is where Q1 occurs. This is not actually Q1, okay? So Q1, which is the lower quartile, occurs at 1/4 of n. So 1/4 of n will be 1/4 of 120. And how much, which student are you looking for?
30.
30 students. Let me work. We didn't come here to lose, Olia. We did not come here to lose. Hey, Olia, I'm going to pause this recording. So, right, 30. Bro said it's 0.9. Yeah, I find looking like it exactly on this, right?
I would say 0.8.
Yeah. Nah, I get 0.9.
0.8. That looks like 0.8.
Nah, bro, you're complicating anything. Watch. 30. Boom and bang. Straight up. On the line there, bro. Zoom in. I am on the line. Watch it. That is 0.9, right? Let me go. So this Q, so therefore, I could put therefore now, right? Therefore, we could come right here. Therefore, Q1 would be equal to 0.9 kilometers, right? Now they want your interquartile range. Your interquartile range would be equal to Q3, which is your upper quartile, minus your lower quartile, right? So just a little point to note here. Q3 occurs
By
proper. Occurs at 3/4 of my total amount of students, right? So this will be so we have 3/4 of n, which should be equal to 3/4 of 120. And we're getting here, my children.
90. In 90th position.
90th position, 90th student, right? Let's work. We got next color there. Boom, bang, boom, bang, boom, bang. Come on, let's work. 90 will be where, boy? Here, boy.
so that looking like 1.5 5.
We exactly on this line. That's what I know. We exactly here. We exactly coming on here. I ain't any autocorrect today, boy. Right. Right. So watch it. Right. We had to locate where our 90th student was. We went across to the curve. Right. That is right here. And then we came down. We landed between 1.5, which is actually 1.50, and 1.6, which is 1.60. In between those two would be 1.55 kilometers. Right. So we're going down. Right, so this will be equal to, no wait, this is Q3. So therefore, I can put here, therefore Q3 would be equal to 1.55 kilometers. Now, your interquartile range will be equal to Q3 1.55 minus Q1, which was what?
0.9.
0.9. Boom.
You get 0.65.
65.
0.65
What they said.
kilometers. Right? Proper. A student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers, right? So we're looking for the probability of more than 1.5 kilometers, right? So let's locate 1.5 kilometers. Remember, we're dealing with more than 1.5, right? So wherever we line up here, it's whatever is above that, right? So let's look. We got a different color. Very good blue. This blue. So 1.5 coming up.
Looking like the exact route.
Exact. Nah, I feel an 82.
So I feel it's 82.
Yeah, I feel an 82. 82. Let me go. Boom bang. 82. Right? So we're talking about 82 students got between 0 and 1.5. How many students got greater than? We deal with this, eh? How many students got greater than?
38.
Come on, let's go.
Yeah.
Let's
38
go.
over 120.
120 minus how much it was? 120 minus 182
82.
all over
Again,
120, which would be 38.
Over 20. 120,
120.
which would be 19 over 60.
19 over who?
60.
Proper. Right? Somebody second that. So complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. So if why press play? Hold on, what did I do? So this would be the distance between 0 and 1.5. They have their midpoint, they have the number of students, right? Then between 0.5 and 1, you have the number of students, etc. Right? Now here would be what's the midpoint between 0.5 and 0.2?
1.75.
Love it. I love it, right? Now, number of students. Watch the heights here. This up here, my children, is a cumulative frequency curve. This is not a frequency table or a frequency polygon or nothing so. It is a cumulative frequency curve, right? So what's something? What I need to do?
make a separate table.
Right. No, we could put on the end here, cumulative frequency, right? So we want to find the cumulative frequency for this column, right? Then we will find this column, and when we minus the 2, we will get one number coming here. And then we could just probably add up these and minus it from 2, and we'll get the next number, right? So we just located for 2.0. So 2.0 would line up with what? No, we had to locate for this two, 1.5 and 2.0, right? So let me go. We'll just record 1.5. We don't have that. 1.5 is 82. Everybody agrees? Y'all see now? Right? So 1.5 would be 82. That's the cumulative frequency, right? We need for 2.0 also. So there you go. We'll do this in blue. That looking pretty exact up there.
112.
I would say 110. Wait, what? No.
I would say 112.
Yeah.
112.
Yeah, proper. Right? 112 is what I would say. So this would come across here. Bean. Beating mean. Right. Way boy, why that shift? Hold on, let me shoot now. Serious people there. We serious people. Yeah, boy. Thanks, sir. Right. Everybody good there? It's right here. It's here. Even though the line a little bent, it would be here. That'll be 112. So this will be 112. That's the cumulative frequency. So watch it. 82, 112. So therefore, 82 plus some number would give me this. What would that number be?
30.
Proper, right? And then just let's just add up all the bad boys.
You
And,
get 6.
and what you getting here?
6.
6. How did Andrew get 6? He did, how much it was? 120? How much it was in total? Students, I think it's 120. Andrew did 120 minus 12 plus 24 plus 46 plus 30 plus 2, and this will be equal to 6. So 6 is the missing number here, right? Give me my final column, please, here, my children.
So I get 52.
52 and
0.5. And 13.5.
so
I get 52.5.
52.5. Somebody second 52.5.
Yeah, 50.
Yeah, that's it.
I hope all the following are going on here. 52.5, right? So, what did they ask us to find here, boy? They just asked us to complete the table and complete the table below and estimate the mean, right? So, hit me the formula for mean.
Summation of F by X over the summation.
God damn.
Ooh, where did I get this from? All right. Divided by the summation of F, right? Summation of F would be this column. Summation of F multiplied by X would be this column, right? For those who completely lost here. So when we add up here, we got 150, and well, obviously the number of students was 120. So let's look, right? This will be equal to 150 over 120. What will be my mean?
1.5.
1.25, and this will be kilometers. So let's look. This is somebody mic on. Right. So this is June 2021, right? 100 students, 100, they don't tell you how much students in the class, right? 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows the result as well as the midpoint of each class interval, right? So question, how many students spent between $80 and $90? 29. How many students spent between $60 to $70?
11.
Right. So everybody knows how to read this table, which is the most dog food thing on earth. Determine the modal class of the amount of money spent. In other words, which of these class intervals, these are your class intervals, which of these class intervals has the most, somebody mic on and I getting feedback. Which one of these class intervals have the most amount of students spending that money? 70 to 80. So modal class would be equal to 70 less than X less than or equal to 80, right? That's my modal class. Moving on. Calculate an estimate of the mean amount of money spent. Give your answer correct to 2 decimal places. Mean. Hit me the formula for mean.
Summation of X over summation of LS.
So, we scrolling up.
So you,
Summation of F, the most dog food thing in the world. What this will be? I think 100. They already give us it above, right? Now, we don't have an F multiplied by X column. Could we get all the numbers that's supposed to come here, please? Let's go.
385. 385.
Yeah, 1
715.
715.
2,325.
2,300.
And 25.
2465.
2090.
So the first one is 385.
385.
So when you add up all your guys, 7,980. Yeah.
7,980. Proper. So let me hit it. This will be equal to, we ain't come here to stick. 7,980 divided by 100 to two decimal places. This will be
9.8.
that's 79.8. And this would be money spent. So it'll be $79.80. So guys, Damian reports that the median amount spent was $84, right? Briefly explain why Damian's report could be correct, right? So if I was to locate my median position, right? So this is the median position. That will be equal to n over 2. What was the total amount of students in the class?
100.
100. It'll be 50.
So we're looking for the 50th student, right? So if we come up here, first 7 students, 7 plus 11,
18.
18 plus 31.
49.
So these 3 class intervals here, watch it, these 3 class intervals have all the students up to the what student? 49th student. So that means the 50th student would be in which class interval? We don't know what the number or the amount of money that the 50th student is represented by, because it does give us a class interval, a range of values, right? Okay? So he could be correct. We don't know if he's correct, but he could be correct because it is a number between 81 and 90. Are we clear? So what I can say here is, since the median student spent 80 less than x less than or equal to 90. Is it 90 or 91? Yeah, no, 90. Damian could be correct. Cool? Everybody cool? The two-way contingency table below gives information on the mode of transportation to school for the 100 students, right? So you have boys, those who walk, those who cycle, those who drive, and the total is 40. So from this going across here, what will be the missing value here?
19.
Then for girls, we could right, we could calculate coming down because 15 plus something supposed to give us 23. Going across, what this will be?
52.
And coming down here would be?
31.
So we completed the table and we got our 2 marks, right? So a student is selected at random. What is student earlier? A student. So what is the probability that he or she is driven? So probability driven would be, if a student we're talking about, we know is out of 100, how many students were driven?
It'll be 40 over 100.
40 over 100, which could be broken down to be what? 2/5?
2/5.
Proper. All working here tonight, boy. One of the
So
girls,
you can't just put 40%.
yeah, if you put 40% correct, full marks, right? So one of the girls is selected at random. What is the probability that she did not cycle to school, right? Okay, let's find out how many girls
52.
who did not cycle, right? Actually, let me run the probability one time, right? Cycle. So probability girls who did not cycle, right? How many girls did not cycle? What will be how we finding that?
34.
34.
So we're talking about 8 plus 26. Over how many girls did we have in all?
52.
So what this will be now?
34 over 52.
It could be broken down into 17 over
17 over 24. 28.
26.
26. I try somebody get to 28 and I even watch to see it's 52 above there. So, so January 2021, 60 students, right? Let me zoom in a little more, right? 60 students took an algebra test, which comprised of 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. Right, so look at the table. Let me ask a question. How many students got 14 out of 15?
9.
9. How many students get 11 out of 15? 6. So everybody knows how to read their table, right? That's the most important thing. Let's move forward. Using the table, determine the number of students who had exactly 13 correct. That's easy. 11, right? That is food. Scrolling down. The modal number of correct answers. So the modal number of correct answers will not be the modal number of students, right? What number am I putting here? 9. So we had 14 students, which is the most amount of students in the class getting 9 out of 15. You seen it there, Ramo? Right? 9, not 14. So the median number of correct answers. The median number of correct answers. So if you want to find the median number of correct answers, and we are dealing with a distribution, well, we're dealing with data that does not have class intervals. You all see any class intervals here, or is it straight data? Straight data, right? Now, once it's straight data, our median position proper, your median position would be equal to n plus 1 over 2, right? And that would be what? How many students we had in the class? So it would be 60 plus 1 over 2. Which number of students are we looking for?
30.5.
We're looking for the 30.5 students, right? So let's go 6 plus 14. 20. 20 plus 2, 22. 22 plus 6, 28. So up to here will be 28 students. 28 plus 2 is what? So my 30th student got a 12, right? And then my 31st student got 1. Right? So 30th student got this, your 31st got a 13. Everybody good there? Right? So let's find our median. So therefore, your median, right, would be equal to 12 plus 13 over 2. Right? This will be equal to 12.5 correct answers, if you want to put it so, right? Correct answers. Right? Everybody good? I find it real unfair that. So the probability that a student chosen at random come in had at least 12 correct answers. At least 12 means what? What are we talking about?
12 or more.
Greater than or equal to 12, right? So we're going up. 12 correct answers would be here, right? Okay? In this column. So how many students got 12 and greater? How we calculating that? How many students got 12? Proper. You're adding all these bad boys here. All, right? So how much again there? So I'm gonna put the work in, 2 plus 11 plus 9 plus 10. I'm putting the work in so you'll see what I'm talking about. We're talking about all these students here, right? Okay? So let me go. This will be equal to 2. So what I did, I added all the people, all the students who got 12 or more, and I'm putting it over 60. So what would my probability be here?
32 over 60.
32.
It break down into 8 over 15.
8 over 15. Everybody get this? This is the probability of getting a score greater than or equal to 12. A group of students wrote a physics examination. Each of the students achieved a grade 1, 2, 3, or 4. The pie chart below shows the results. So this just means a grade 1, how much students, how much degrees represents the students that got 1. How many degrees represent the students that got 4? You can't just watch this and say it's 90 degrees there. How many students got a 2? How many students got a 3? Right? Now, they just confirmed on it here that 39 students achieved a grade 3. Determine the total number of students who wrote the examination. So watch this. 117 over 360 multiplied, meaning that fraction of a number which represents the total amount of students would be equal to how many students? Am I here earlier? 39. Right? 39. I know. 39. Right? So that fraction of x is equal to 39. X represents the total number of students, right? So how do I work this out? I carry this fraction over here, and what do I do with it? I divide, right? So x would be equal to 39 divided by 117 over 360. And when I build that automatically, you get the 120. 120. So the ratio of the number of students who achieve grade 1, 2, and 4, which is a real kind of ISO kind of thing here. You gotta watch this properly and see it's a 4 they have here. So 1, 3, and 4 would be 2 to 4 to 3. A student passed the exam if he achieves a grade 1, 2, or 3. So it's a real tie-up scene going up here. How many students passed the exam? So you basically know 3 is represented by 39 already. We need to find for grade 1 and 2, right? So in order to find for grade 1 and 2, what's the total parts? Watch it. Total parts would be how much?
9.
It'll be 2 plus 4 plus 3, which will be equal to 9. Everybody good there? Soak that in, right? So that 9 parts, right? That 9 parts, therefore 9 parts would be equal to how much students? Right? You all seen it there? 9 parts would be equal to 91 students, right? So 9 parts would be equal to 91 students, right? So how much one part would be? I believe I know watching this and saying, but how this is 91? I know watching this. Where I get 91 from? Sum of 81, right? So it'll be 81 divided by 9, which will give me what? One part would be 9, right? So 9 students represent one part. So let me function. We're trying to figure out for 1, 2, and 3, right? So we already know a 3 is 39, but we know 1 is represented by how much parts? 1. So your grade 1 would be equal to just 2 multiplied by 9, which is 18. And your grade 2 would be how much? 4 multiplied by 9, which is how much? 9 fours are 36. So we have 18 students here. We have 36 students for grade students, right? For grade 2, I should put the word grade here because other mind catch what that mean. Grade, right? And grade 3 was how much? Grade 3 was given 39 students, right? This is our next question that has plenty working, right? So therefore, the students who pass will be what? That's what you get, bro? Huh? You do the same working? Or you do different? Students who pass.
So, yeah, what I do?
Uh-huh.
Yeah. I do 360
93.
minus 170,
117, yeah?
243.
Right.
Divide that by 9. They get 27, and then I put 27 by 2, 27 by
Right. So you just use angles. Andrew, you did that too?
I use angles and I add it up and I put 39 over 17 by all the
It's just like one extra working you had to do there. Just one extra working. So 93 students would be the amount of students who passed, right? So any other questions? Determine the value of the angle for the sector representing grade 1 in the pie chart, right? So your grade 1, right? Your grade 1 would be what? How many students got grade 1s? That's where we're taking it from. How many students? 18. So grade 1 will be 18 over how many students in total? How many students we had in total? 120 multiplied by how many degrees we have in a pie chart, right? Because we're trying to find the angle in the pie chart. So 360. And when you multiply this, what you get? Where again when you work out this? 54. Now the flip side of this is men who did it the next way above. You just had to write the answer. You just had to write the answer. A group of 100 students estimated the mass m grams of a seed. The cumulative frequency curve below shows the results, right? So you have the mass of the seed on your x-axis. You have your cumulative frequency, which will be the number of students on your y-axis, right? What will be the total amount of students in the class from looking at the cumulative frequency curve? 100, right? Proper. Yeah. So using the cumulative frequency curve, estimate the median. So my median position would be n divided by 2 for this cumulative frequency curve, right? N divided by 2 will be equal to how many students do we have in total in the class? Did this state it above? Yeah, look, this stated above, right? But from just watching the graph, you can see it's 100. It's the top point in your cumulative frequency curve here, right? So we go now. Right. So this will be 100 divided by 2. We're looking for the 50th student. Everybody good there? So let's work. We go in here now. 50th student, they're coming. So bang. It's exactly on that. I go with exactly 3.2, brother. I ain't get the autocorrect. So this will be 3.2. I know I ain't getting the autocorrect. So my median would be, so therefore my median would be equal to 3.2 grams. Everybody good there? Yes. So your upper quartile now, which is represented by Q3. So Q3 occurs at 3/4 of n, which is 3/4 multiplied by 100. So what are we looking for? Which number student? The 75th student to get my upper quartile, right? So let's work. Come on, guys, let's work. So we're going 75th. Where 75th would be? They're going to have a different color. 75th would be here, bang. Hey, I missed that way. That's how we will carry up the whole line. Carry up the whole line.
So looking like 4.2 or 4.3.
That would look like?
I think it's 4.3.
I'm lying in trouble. Let me over. 4.3. Boom. Bang. Bang. I looking like in between here. In between here. Coming down here. Hey, what going on with this thing this morning? So Q3 would be 4.3, right? So I write in 4.3 underneath here. 4.3. Because this is 4.2. On this side is 4.4. 4.3 would be in the middle, right? So now I would say, therefore,
Morning, sir.
morning. Therefore, Q3 would be equal to 4.3 grams, right? Now, your semi-interquartile range. So I'll write two formulas here, right? Your interquartile range would be equal to Q3 minus Q1. That is interquartile range. Now, if they ask you for semi,
Q3 plus Q1 over 2.
proper interquartile range, could you write it down, please? Would be equal to Q3 minus Q1 all over 2, right? And I could even put here where Q3 is the upper, right? Upper quartile, and Q1 is the lower quartile. Everybody good here? Right? So for the lower quartile, this will be 25. You're looking for the 25th student, and it works out to be 2.3, right? So therefore, our semi, right? So let's write it in here. So therefore, well, Q1 would be 2.3, right? So therefore, our semi interquartile range would be equal to semi interquartile, right? Q3, I'm writing it over Q3 minus Q1 all over 2. So this will be equal to 4.3 minus 2.3 divided by 2. What are we getting here?
1.
1, exact 1?
Yeah, 1.
This will be equal to 1, right? That's my semi-interquartile range. So we're looking for the number of students whose estimate is 2.8 grams or less, right? 2.8 grams or less. Let's see if we could identify that. All right. There we go. What to use here, boy? Let me use blue. Baby blue. 2.8. Where I'll be? That'll be here. Everybody agrees? Exactly on this.
So right 38.
Yeah, that's exactly 38. Exactly 38. I don't have no problem with this here. Exactly 38. Okay? So 38 students scored 2.8 or less, because 2.8 or less, we're talking about all these grams here, right? So that'll be all these students represent 2.8 or less. So the number of students will simply be 2.8. 2.8. No, not 2.8. That's the amount of grams, right? The number of students will be 38. So number of students will be 38. Everybody good there? And then you all can figure out part 2. Figure out part 2. And part 2 is 2 marks, eh? This is our frequency table. So for the part 2, they said a student chosen at random, is chosen at random, find the probability that the student estimated the mass to be greater than 6 grams. Look, 6 grams here, right? So how many students got greater than 6 grams? We're talking about this 6 and this person, this one person here. Because they got a mass between 8 to 10 grams, right? Which is greater than 6. So the probability of greater than 6 will be equal to those 7 children out of how many children we have in total? 100. That's it there, no? So we have June 2019, right? They said the cumulative frequency distribution of the volume of petrol needed to fill the tanks of 150 different vehicles is shown below. So let me ask a question. How many vehicles had a volume between 11 to 20? How many? 24, right? How many vehicles had a volume between 21 to 30?
59.
Nah, that's wrong. That's wrong, big brother. That's wrong. What's that column? What that column sitting above there? Cumulative frequency. So that means if you have a frequency column, we just play with it here, right? This will be 24. Here will be what? 25. And what the next one will be? It'll be 59. 101 minus 59 as well. 35, yeah, proper. 35. And what this one will be? 101 minus 59. What that is? That's
42.
42, you sure? 42? Yeah, boom bang, 42, yeah. And then so forth, right? You see what happened there, Preston?
Yes, sir.
Right. So we're looking for the class, for the class 21 to 30, determine the lower class boundary. So are the boundaries my 0.5s or are the limits my 0.5s? Who remembers?
Your boundary is a 0.5.
The boundaries are your 0.5. So if I was to say my lower class boundary, I'm talking about, is it 21.5?
20.5.
Thank you. 20.5, right? This is my lower class boundary, right? Then, if I was talking about my lower class limit, what's the lower class limit for this?
21.
21, right? What is the upper class boundary?
30.5.
30.5.
Proper. And then your upper class limit would be 30, right? This is just some additional information here, right? Okay? So, this is what the question asks for. Now, we want the class width. What is the formula for class width? Somebody hit me there.
Class boundary. Take away the class boundary.
So I just put in abbreviations, right? So upper class boundary minus minus lower class boundary all over. No, it's class width. Now if it was class midpoint, it will be the upper class boundary plus the lower class boundary divided by 2. Yeah. So this here will be what? This will be equal to 30.5 minus 20.5, which will give me what?
10.
10, proper.
Vehicles.
So let me go. How many vehicles were recorded in the class 31 to 40, right? So this is where you'll have to work your frequency column. 31 to 40, we done work out that, right? So let me put working, eh? So 31 to 40, number of vehicles, right? Number of vehicles, right? So the working would be 101 minus was it 59? 59, right? I was going to put 59 plus, but it's just 59. So this gave us the 42, right? It was 42, eh? Yeah, 42. Okay? Let's go. A vehicle is chosen at random from the 150 vehicles. What is the probability that the volume of petrol needed to fill its tank is more than 50.5 liters? Leave your answer as a fraction, right? So we want the probability of more, greater than 50.5, right? That will be equal to, let's locate where 50.5 is. 50.5 will be the lower class boundary here, right? 50.5. So we only talking about how much? We had to work out this. How much this will be? Give me this one here. Let me put all one time. Here's 42. What's next? 29. 129 minus 101 will give me what? How much? 28. And then 150 minus 129 will give me how much?
21.
21. Right? So we're working with 21 vehicles out of how much?
150.
What is going to be broken down to be?
7/50.
50. Right? And look what it said. I always leave my probabilities as fractions, so that wouldn't even affect us, right? I always leave it as a fraction. Right. Brian estimates the median amount of petrol to be 43.5 liters. Explain why Brian's estimate is incorrect, right? So let me locate the median position. That's what I want to do. I want to locate the median position. So is this a question with class intervals? Yes. So we could do n over 2, right? What was n for this question? I believe it was 150. 150 was the total amount of students. So we're looking for the 75th student, right? Let's see which class interval The 75th student is in, and let me see if Byron talking Tata here, right? But look at here, the 59 student, well, this is the first 59 here. So we have 24 and 35, that will be 59, right? So the 75th student will be in which class interval?
31.
It is in this class interval. Your median will be in here. Median position leads you to this, right? Okay? It would be because between 59 to 101, 75 would be there. So that means that our median volume in liters would be a number between what? It would be a number between 31 and what big man Byron come and say? 43, right? So I could just put since the median position is in what was 31 to 40, Byron is incorrect. On the partially labeled grid below, construct a histogram to represent the distribution of the volume of petrol needed to fill the tanks of the 150 vehicles. Right, so wait, yeah, we're doing that for sure, but our frequency is on our y-axis. But what are we going to put on our x-axis? We put in the volume in liters, right? Now we go in from zero, we could go from 0. We just don't have the first class interval, right? But we could go from 0 straight up to 60. Let me see if it would fit, right? We could go in same tens like what they're doing here, right? So this will be 10, 20, 30, 40, 50, 60, right? And underneath here, I'll put volume in liters. Come on, let me get our 3 mark. All right, let's go. These bad boys here want the values one time. So for 11 to 20, we have a frequency. Remember, when you join a histogram, it's frequency you're working with, right? Not cumulative frequency. So your frequency will be 24. So that bar going up to 24. Now, points to note. What am I drawing the sides of my bars on? The lower and upper class boundaries, right? Histograms are joined together. So you're going up on 10.5, going across on 24, coming down on 20.5. Everybody good there? Do I need to say it again? No. You're going up on 10.5, coming across on 24, coming down on 20.5. That represents 11 to 20. The 11 to 20 bar, right? So there we go. 10.5 would be here, right? I'm going as close as possible. 10.5, you're coming up. You're stopping at 24. Everybody good there? And of course, this thing is... Right, so this is bar number 1. Came up on 10.5. Went across on 24, right? So look, 24 is here, right? And then came back down on 20.5, not on 20, right? Now, the thing about this here is when you join the next bar, you have to continue with this 20.5 line, right? So watch it here. For this one here, you're going up, well, you're going up a little more to 35, but you're going up on 20.5, which you already started that line, and then coming back down on 30.5. We good there? Boundaries is what we're working with, right? So we're going up, up, and up here. I find this is like one of the easier things to do in mathematics, right? So you're going up.
For sure.
35, right? 35, and then we're going across to 30.5, right? Coming down. I join is free, I don't know. Okay? So we coming down here. All of a sudden, they starting to give me autocorrect. Right? So this looks a lot better here. Right? Scrolling up, let me see what we're going to next. 31 to 40, which will be a going up on 30.5, coming down on 40.5. This will be 42. Right? So we're going up a little more. We're going up to 42. Let me see if I can get this line to this extent. Now,
Go from closer.
we're going up to 40, 42.
28.
28 now, right? So that means we're going up to 28 here. Okay, so that's it's like a coming off this line here now. So 28 would be here. Right, so coming off this line now, you're going across to 50.1, coming down here, boom. Right, coming down,
Hey.
winning.
Alright.
Next one, what's the next one?
21.
21. So you're coming here now, coming off this line, 21. Right? Yeah, bro, morning, morning. Nothing, what's up? January 2019, right? They said a survey was conducted among 48 persons to find out what mobile network they use. The table below shows the results of the survey, right? So you have the mobile network names above there, and then you have the number of persons, right? If this information is to be represented on a pie chart, what is the angle of the sector that would represent O phone? So O phone would be 10 out of how much?
48.
48 persons in all. Multiply by how much degrees in an entire pie? 360. So how much is to be?
75.
How much?
75 degrees.
75 degrees.
You know me know, right?
That don't know. If a question come like this is real work. Using the circle below with radius shown represent the information in the table above on a clearly labeled pie chart. So we already figured out how much degrees represents O phone, right? This is O phone. O phone.
Open.
Let me do for wire tech. We had to find the degrees for all, right? So let me go wire tech. Wire tech. It's TECH, yeah, tech. Wire tech, right? Wire tech would be equal to how much persons? 20 out of 48 or 20 over 48 multiplied by 360. How much degrees you working with here?
150.
150?
Yeah.
What else we leave out? Digilec.
You'll get 90 for that.
How much is this? 12? 90 here, right? Next. Other. Because we don't find O phone, right? So we go in other.
You'll get
Other
45
6.
for that.
Alright. 6 out of 48 multiplied by 360. How much you get here?
45.
45 degrees, right? Now, in order to work this, I had to go on my app now. So I use my protractor. I just run it over, right? Because I showed tap like people that didn't understand, right? I started with the line that CSEC gave us. I measured 45 degrees, which will be in between here, right? I put a mark. I shifted my same protractor to the mark and I drew a line. That's the line I drew. Then I measured 90 degrees. So 90 degrees is up here. I put a mark. You seen it outside the circle here, right? Then I shifted my protractor. I really shifted it. I shifted my protractor to this line and I made, well, this point here, and I made a line, right? I made another line. Here would be 90 degrees. Then the next angle was 150. I marked 150 down here and I shifted my protractor, or you could just use a ruler and draw the final line down here. Boom. So we're going to label them now, right? So we go in. The first one was 45, right? 45 degrees. And this is other. Because CXC said they wanted a clearly labeled pie chart, right? I want to show you all where they said that, right? We go in here. Clearly labeled pie chart, right? So we come in here now. So let me go. Next one was what? 90? And what this was?
Digilec.
Digilec. Next one was what?
Wire tech.
150 degrees wire.
When you realize how I attack, but
And the last one would be
Phone.
phone, and this is 75 degrees. Well, phone. Right? Proper thing. Properly. The incomplete table shows the results obtained by 200 boys and 250 girls on a Spanish exam. So you have the grades. You have boys, a boys column, you have a girls column, right? They give us standard deviation at the bottom. Now we did standard deviation this week. You remember, the greater the standard deviation, what does that mean?
when you find the mean,
The value is more spread out.
Right. So if the mean in the middle here, the value is more spread out. Okay. Now the lesser the standard deviation, it means that the marks are closer to the mean mark, right? So let me go. A girl is chosen at random, determine the probability that she achieves a grade 1. A girl was chosen at random. So probability of girl girl and grade 1. Now let's put and grade 1. Grade 1, right? Or girl with grade 1. What'll be? Girl with grade 1.
62 over 250.
62 over 250, right? Girl with. I didn't want to write out all them thing above there. Girl with grade 1 would be 62 out of 250. This can be broken down?
yeah, it's just the one.
Yeah, so 31 over 125.
31 over 125, right?
So you put 67.
What was?
62.
I glitched by. Since the first question I glitched. 62. I ain't drink none for the day too. Coffee just get sharper, innit? Had a real hard week, boy. This week was real hard. I was 250, right?
How coffee like make you sharper, sir?
What percentage of the boys who took the exam achieved grades 1 to 3? So it would be 38, which would be the 4 and the 5 minus 200.
Hold it.
What's right? Let me go. So just to reiterate, right? What percentage of the boys took achieve grades 1 to 3? We're talking about all these children here. How do I not including the 4s, right? How do I calculate that? Jordan and Andrew done belt it out. You're gonna do 200, which is the total, minus 38, which will be these, well, the children that got 4s and 5s, right? So we go back down here. Percentage would be I'll put it working here. 200 minus 38 out of how many boys in total?
200.
200. If it's a percent, we're trying to find
Over 100.
Multiply by 100.
over 100, multiply by 100, right? And what would we get as our percentage here? It is 81 over 81. 81% is the answer. All right, so it'll be equal to 81%. Talk done. Right, so this standard deviation is greater. So it means that wherever the mean is for boys, their marks are spread out. Boys' marks all over the place, right? But the girls, their mean is probably high. Their mean is probably like around at 2, and they got plenty marks close to 2. The boys' marks are all over the place, okay? So let me go. So consider standard deviation care. So the comparison is the girls did better than the boys because their standard deviation is less, right? Is less. Okay? Right. So students in a group were asked to name their favorite sport. Their responses are shown in the pie chart below. So this is what people let's talk about when they say long-term exams. This is to be real easy. This is real easy, right? So if I want to find x, look at how much food this is, right? X would simply be equal to 360 minus 94 plus 45, right? Are we getting there? 221 degrees, right? That is what x would be equal to. That question done. I'm marking it back. What percentage of students choose cricket, right? So we need to find the amount of students who choose cricket, right? Percentage cricket, I'm gonna do it as 1, right? So this will be equal to how much the amount of degrees of cricket was? 94 over 360 multiplied by, and how much again?
26.11.
26 point
1%.
and I just put 0.1, right? That is what people say when they mean that long time exams were extremely easy. Right, let go. So the group, given that 40 students chose tennis, calculate the total number of students in the group, right? So 40 students chose tennis. So let me hear you. What would be your ideas? It's the same thing like what we did earlier.
365 over 45, but I have my division on.
Right, it was 45. I would do 45. Well, I know what you do is 360. 45 over 360 multiplied by the total amount of students, which is represented by x. We calling this x, right? The total number of students would be equal to the 40. This is just like the question we did above with the 39, right? And then I just carry this here, divided. X would be equal to 40. I'm going to get the same thing you get though. 45 divided by 360, and we're getting here.
320.
You get that, bro?
360 over 40.
Right. So the diagram below shows a frequency polygon of the number of goals scored by a football team in 25 matches, right? So how much goals was scored in 5 matches? 0. In 7 matches, we had 1 goal in those 7 matches, right? Then in 3 matches, we had 2 goals in each one of those 3 matches. Right? That's how to read this line graph. It's a line graph, right? So how many matches had a score of 6 or 6 goals? 1. So only 1 game had 6 goals, right? So we go down here now. Let me complete this bad boy. Number of matches. So for 2, how much we put in here? 3. And then for 5, what we put in here? 2. Dog food. Right? A whole mark for that, no, guys. Can't believe CSEC long time, you know, giving away marks. What is the modal number of goals scored by a team?
1. No.
The modal number of goals. So
1.
1. Correct. Yeah. So your modal number of goals will be equal to 1. Right? Because there was 7 matches in which 1 goal was scored. Right? 7 matches in which 1 goal was scored, right? Let's see what's next. Determine the median number of goals scored by the team. Now, this is straight data, right? So your median position,
It's not N2.
right, would be equal to n plus 1 over 2. How much matches it was in total? Anybody remember? I ain't even remember. 25. Look at it. Above 25, right? So it would be 25 plus 1 over 2. 13. We're looking for the 13th student, right? What score did what goal did the 13th match have, right? So 5 matches had 0. 7 matches had 1. 3 matches had 2, so 2, right? Everybody catch that? 5 matches, it had a score of 0. So, hey, how this data looks? It's like 5 zeros, bang, 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 bang. Then you have 7 ones, 1, 2, 3, 4, 5, 6, 7. Then you had 3 twos. So even for the mode, what's the mode for this data here? Just I'm watching it here. How much ones it had? And that number occurs the most. So that's why the mode is 1 and not 7. The mode is 1 and not 7. And then you have your number of trees, you have 3 trees, and etc. 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 right? So your 13th student would have gotten a, well, not 13th student, the 13th match would be a 2. Right? So therefore your median, and that's what median, it means median number of goals will be 2. Right? Calculate the mean of the goals scored. We do this whole week. What's mean? Mean is equal to
The summation of f by x over the summation of f.
Alright. Question. Which one here would be my F and oh god, CSEC give it away, boy. I want to see if you all knew which one would be X and which one would be F, right? Your X would be like your sample, right? So you have 0, 1, 2, 3, 4, 5, 6, and then your frequency would be how much matches had 0, how much matches had 1, etc. Right? So CSEC don't give it away. So we need the summation of this bad boy here, which is 25. We don't know that. But we need to have our F multiplied by X column. Well, I'm going to do it on top here now. F multiplied by X. F multiplied by X. Hitman, give me. What's the first one here? First one here. Proper. Right?
54.
So if I were the summation of all these bad boys, right? It will be you're adding. Right? You're adding. And where you get 54? So there you go. So it'll be 54 over 25, right? Proper thing. Proper thing. 54 divided by 25.
2.16.
2.16, which is close to the median here of 2. Well, goals, right? Goals. Say that again? 2.16. Oh.
Yes, sir.
2.16. There you go. Hey, that's it. I know where to go.
So you can scroll up by
By where?
part A3.
Right, look, A3 above there. So here we're going on, guys. I actually want to finish off these cluster questions, and I want to do like 20. I want to do some old full papers. So you do like 2018, the full paper, 2017, well, that'll be January 2018, the full paper, and then I'll do June 2017, June 2016, and I also want to do over like the full paper as one, January 2026, June 2025, and January 2025 as one. Them papers, I want you all to focus on it, right? So I'll see you all this evening for Trino. Take care of yourself. We out. Later.
So that's part B though. Scroll up like one more, please.
Oh, scroll up one more.
Yeah.
Bye, guys, online. Okay, bye. Right here.
Part A, part A.
Part A. Right here? Yeah.
So that's supposed to be 320 students that degrees.
Yeah, correct. Yeah, correct. I'm put on the recording, eh? Yeah, this supposed to be students. Huh? Yeah, I'm going to Hey, you gonna or you going to the shop? Alright, good. Yeah. Alright, bro, later.